Windows AI platform takes shape. Windows AI Foundry supersedes Windows Copilot runtime as Microsoft doubles down on delivering AI-powered application on Windows. In May 2024, Microsoft announced the Windows Copilot runtime targeted at its then new Copilot Plus PCs. It provided a mix of innovations from on-device small language models to improvement to Windows support for NPU, neural processing unit hardware, new artificial intelligence APIs for Windows applications, and an ARM port of popular AI development and tuning tools. The delivery that did too much of the past year with the loss of key features. The AI APIs finally reaching a stable release. The Windows Copilot runtime is a loose collection of tools to build Windows AI-based applications that run on your PC. It's leveraging Microsoft Phi Silica small language model and a collection of other models to offer computer vision and audio services. There's no need to use expensive cloud-based models. Windows Copilot runtime applications are intended to use only local resources. So hence, the requirement for at least 40 trillion operations per second of dedicated AI accelerator chips. With that first reach, those capabilities were limited to a small subset of PCs. Now they are pretty much standard. Intel and AMD's latest generation of silicon provide the same NPU capabilities as the ARM hardware used in the first Copilot Plus hardware. They are now a lot of affordable. Recently launched Surface devices use a cheaper NPU-based Qualcomm chipset and start at $799. If there was one thing we've learned in the past few years of AI transition, it's a year is a very long time. New technologies have arrived that make it easier to ground AI in real-world data, and the number of open-source models that are endpoint ready has grown dramatically. So Microsoft is bundling new small language models in new release of Windows, though not always a developer success. So with the low-cost PCs now capability of developing and tuning and running complex AI models, Microsoft needs to bring the various components of Windows AI development into the same type of platform as a unified AI foundry, so it makes it easy to build into your Windows development tool chain. Introducing the Windows AI Foundry. 1 year later, Microsoft is evolving Windows Copilot runtime into a new set of tools that delivers an AI development platform and rebranding it as Windows AI Foundry. At the same time, Microsoft is adding new abstractions to DirectML to make it easier to run models on a wide range of PCs and rebranding it as Windows ML. A key component is FoundLocker, an AI runtime that loads and runs the right AI models for your hardware. FoundLocker is now in preview on Windows and macOS. Unlike the Windows Copilot runtime, the Windows AI Foundry is no longer focused on Copilot Plus PCs. Instead, it builds on the top of the new Windows ML platform to support AI inferencing on CPU, GPU, and NPU. Microsoft still Microsoft will still provide some APIs for Copilot Plus PCs for now through the Windows App SDK. Windows AI Foundry builds the new Foundry local application as a CLI tool for managing available models, with support for other model catalogs beyond Microsoft. The aim to make it easier for developers to build AI applications in Windows and for users to install to use them as wide of a range of PCs as possible. Microsoft will roll out additional Windows AI APIs in the Windows App SDK for devices with MPUs that ship with its own AI in-box models. So as Jatinder Man, partner director of product, Widget Platform and AI Runtime, told me, we are bringing the full power of AI Cloud to client. You can think of it as a system for running, customizing and build AI models directly on Windows at scale. One key new feature in a new Windows AI Foundry is support to LoRa, low-rank adaptation, tuning algorithms to for built-in Phi Silica model. You will be able to use the AI toolkit in Visual Studio Code for tuning. There is also a way to quickly add and evaluate existing LoRa adapters to Phi Silica in the latest version of growing AI Dev Gallery application from the Windows Store. Tools like this are an important part of giving developers the necessary skills to tune AI models and ensure the results are closer to what your applications need to deliver. Tuning is a useful way to add further grounding to application, reducing risk associated with hallucinations by using your own data to direct your output. In line with the Azure adoption of the Model Control Protocol, MCP, Windows will be adopting MCP to integrate the AI actions with the applications. This will give your AI applications the ability to quickly use on-PC applications as agents and build them into intelligent workflows. Applications will be able to expose specific features as app actions which can quickly become MPC servers, providing new building blocks for custom flows. Using Foundry Local. I tested Foundry Local on both an x64 PC with an NVIDIA GPU and an ARM PC with a Qualcomm NPU. The first, I downloaded 5.4 Mini on both devices. This ran using the GPU and NVIDIA devices and the CPU on the ARM machine. It's important to note the Foundry Local profile your PC hardware and automatically download the best version of a model. If you want to see the current library models, use the Foundry model list command. This shows the runtimes are supported for what model. For the first test, it turns out that the NPU inferencing isn't supported by the model. The list of models shows that what is supported on the devices you're using. So see what has Qualcomm NPU support. You need to run the list on the ARM device. This shows that the 5.4 Mini Reasoning had NPU support and I was able to use the NPU performance monitor in Task Manager to see that it was using the accelerator. When I gave it a prompt using Foundry Local, not all models have been optimized for all NPUs, and what's available may differ from architecture to architecture. Hopefully, more models will be available for NPU inferencing soon. The local prompt is an effective way to get started, but it's more useful to use Foundry Local with its support for its own SDK and the OpenAI SDK. It exposes a REST endpoint for your model that you can use to write code against. You can use the same REST codes with a local endpoint as you would with a cloud endpoint. Microsoft has finally developed the tools we need to build local AI applications. Foundry Local manages the models on PCs, both for development for users, providing necessary APIs to move code from the cloud onto our PCs, taking advantage of dedicated inferencing accelerators and removing load from cloud data centers. A foundation in Windows ML. Having Windows ML has a common framework for inferencing is another key part of this new Windows AI development platform. It provides a standard way to host and core Linux models using the most appropriate runtime environment for PC that's handling inferencing. Your code can use the Foundry Local SDK and CLI to check the available for model type for your application. Download it and keep it up to date while Windows ML ensures that it runs. You can think of it as a foundation for Windows AI Foundry. Everything sits on the top of it, and without it, nothing works. Foundry Local isn't the only model library supported by Windows AI Foundry. It works with public catalogs such as Llama and Hugging Face as well. Keep in mind that Microsoft has done the work to optimize its own library of Foundry Local models for you, and you may need to do additional work to get the right implementations of other models in place. The current preview of the Foundry Local installs as the standard applications. However, the plan is for the common part of the Windows, ensuring AI applications written to use the its SDK and APIs can run without requiring users to learn how to use Winget. This will ensure that the Windows ML is a part of the platform and will simplify running models from the Foundry Local cache. Since Foundry's Local is Windows application, so there's no need to managing execution providers as they will be selected and downloaded as needing along with the latest version of models. Targeting Windows ML should help future-proof your code as your PCs, GPUs, and NPUs roll out. It will provide a common hardware-independent environment for endpoint AI code. The code is a cross-platform successor to the original Copilot runtime that will support all Windows PC, not only those with the GPUs and NPUs. Connecting with the Model Context Protocol. At a pre-build 2025 event, Microsoft CTO Calvin Scott talked about the development of what he called the Agentic Web. A theme CEO Satya Nadella returned to in his build keynote. And the part of this idea is creating new tools based on a Model Context Protocol, which makes it easy to connect applications and data sources to AI application. Scott describes the MCP as the HTTP of a distribution AI platform. Although I don't quite agree with him, I consider it to be closer to technology like COBOL. He makes an important point. We need ways to ground AI application in real-world data without having to build complex and expensive embedding-based vector indexes. And we need to give applications that are part of the AI-powered workflow the necessary tools to control what they share with agent queries are wrapped up in a standard set of services that can be plugged into AI workflows. It's not surprising to see Windows AI platform delivering its own MCP framework that will connect agent to Windows application to to form an agentic Windows. This will allow the code to expose specific features to applications, avoiding the complex of having a genetic operators mode that would require UI access. Divya Venkataramu, the director of product marketing for Windows Developer, described as offering a standardized framework for agents to interact with Windows native apps via their MCP servers. Building MCP into OS requires more than tools to add servers to APIs and needs a way to allow the agent to discover available agent ready to incursion in agentic workflows. This comes in the shape in the MCP registry that's tied to enhanced security models that allows the server to list privileges, control, and auditable operations. Windows will now expose its own MCP servers for specific features. Initially, it will only offer a subset of each surface, but over time, more features will be exposed to via MCP. One interesting scenario from my conversation with Venkataraman was using an agent to build out a developed environment on a PC ready to start coding. We start by going to GitHub Copilot in VS Code and asking the agent to set up the environment for you. This connected to WSL MCP server security. I will be able to install the right Linux distribution for you. If I wanted to go install my WSL environment, it takes a long time for me to even figure out the latest version of the distro that I want, then loading, locating the distro, and installing all the packages. Now we'll be enabling the agent to do that. And lets developers focus on getting ready to code by getting ready to code by getting the environment itself set up. Add MCP servers to application with the AP actions. You can use available MCP SDKs to expose specific application features to agents, which work with the existing APIs. Alternatively, as Microsoft is introducing App Options, a new feature for application developers that wrap specific application features as MCP servers, which like adding a webhook to a service and exposing the behavior you want to use in an agent. Unlike webhook, app action definition include the semantic description to build AI-powered agent. At the heart of an app action is the concept of identity. These are the object passed to actions to return from them. Things like simple variables, more complex sets of results, or documents, photos, or text. Under the JSON object, you can use familiar techniques to build and deliver app actions, and Windows will include new APIs in WinRT ready to help you quickly add and support to your code. It's concurrently supported by preview release of the Windows SDK, which you need to declare as part of your project. Build an app action start with annotate.json, which defines how the action is described in an agent builder, followed by inputs and outputs and how it's invoked, for example via com GUID. You do need to write to the right handlers in your code to work with the action. Using the action provider class, which implements asynchronous interfaces, your provider uses the username defined in the app action code.json to route input to the right code, sending a response back when the action has completed. Microsoft has an app action playground to test your actions. When they are registered with Windows, you are able to them into playground. You can You can then send the input entity using Playground to see what the application's response. Applications can then set the ability of their actions. For example, toggling them on off when you launch and shut down your code. This ensures that the applications agent can only run under user control. With MC support in tools like Visual Studio Code, VH GitHub Copilot, there's the prospect of having an AI-driven toolchain that links that feature level between code tools and design tools, or code tools and cloud services. What you need is for tools to start adding their own servers, and we can build them into a flow. A platform for an AI on Windows. It's clear that Microsoft has forgotten what made Windows successful. The fact that it's a platform. At the heart of this new platform, Windows AI Foundry and the associated tools are designed to build AI into Windows applications using any and all kinds of models, especially open source ones, and provide ways to link the code on your PC to a local instance of wider agentic web. This means Microsoft is protecting users by providing necessary tools, managing secure MCP servers. It's nice to see that much of what was announced April 2025 is ready to download and run, though it's clear there is still a lot of tools defined and folded into Windows. For now, start by finding bits you need to build the test the Windows Agentic AI feature before they are bundled onto every PC, whether they are running on CPU, GPU, or CPU, GPU, and NPU. The tools are here are ready for you to get started. You can ship code as NAS. Tools are available to users as part of a future Windows update. Thank you for your time. See you next time.